Welcome to ECHO-JEE. Now we are continuing the chapter that is ellipse here. In this ellipse, in last session we have discussed about the 4 different types of ellipse here, and now we have to discuss some more factors, some more terms involved in these 4 types of ellipse here. So the first, this table includes here, this is equation of ellipse here. This is equation of ellipse completely. This is equation of ellipse, and in this one, the first standard form of ellipse formula, the standard form of ellipse is x square by a square plus y square by b square is equal to 1. Whenever the b square, a is greater than b here. Whenever a is greater than b, a is nothing but here the x coordinate point here and b is y here. So this is the first shape of the ellipse here. So let us draw the diagram for the first type of ellipse. So this is axis here. So here this is an ellipse, and here the first one shows the figure. The first parameter shows the figure of an ellipse x square by a square plus y square by b square is equal to 1, that is a greater than b here. And the second center for this ellipse is the center. This is the center for this ellipse. This is 0, 0. This is center C here. And next one, what is S? What is S? What is mean by what is S? A parabola is intersecting the ellipse is intersecting the major axis at 2 points is called vertices. This is nothing but here I am taking A, this is A dash, and the point is here. So plus or minus A, that is this is A comma 0 and this is minus A comma 0. This is A comma 0 and this is minus A comma 0, and the second point is vertices above. And the foci. What is meant by foci here? The plural form of focus is called foci. The plural form of focus is called foci. And now this is the foci. This is one focus. This is S here. This is S dash here. So what will be the focus here? When the ellipse is in the form of x square by a square plus y square by b square is equal to 1, a greater than 1. This is the plus or minus a comma 0. This is a comma 0. And this is minus a comma 0, minus a comma 0. And the next one, directrix. What is meant by directrix here? This is directrix, this is one directrix, and this is also one more directrix here. So this is nothing but z, and this is also z dash here. So this is directrix, and the this directrix is intersecting the major axis at 2 points. This point is called, generally we can call it as, this is L and L dash, and the intersection of these points Z and Z dash. So the directrix which is intersecting the major axis at one point, and one more directrix intersecting other side of the major axis, that is Z dash here. Then the points are Z dash, Z and Z dash are plus or minus AE by plus AE by 0 and minus AE by 0. This is minus AE by 0. This is the one more point for the directrix of an ellipse x square by a square plus y square by b square is equal to 1. And the next one, equation of end points of latus rectum. What is mean by latus rectum? What is mean by latus rectum? A line which is perpendicular to the major axis and as well as passing through focus is called latus rectum. This is latus rectum here. So the end points of latus rectum here, end points of latus rectum, this is 1 point and this is 1 point. This is end points of latus rectum. Consider this is K and K dash here. Here these two are end points of latus rectum. Here that is plus or minus AE comma plus or minus b square by a. The first one AE comma b square by a and minus AE, this is minus AE and minus b square by a. This is the end points of our latus rectum here. And the equation of major axis here, in this standard form of ellipse, this is the major axis. This is the major axis, and the equation of this major axis, that is x axis, then the equation will become y is equal 0. Then the equation will become y is equal 0. This is important one here. This is an x axis. Then the equation of major axis will become y is equal 0, and the equation of minor axis will become perpendicular to that one. Then x is equal 0. Why? Because it is having origin 0 comma 0. That's why we are getting equations are x is equal 0 and y is equal 0. If it is any other center, alpha comma beta, a comma b, any other center, that will be different here. That will be different for the equation here. And equation of latus recta. If you want to find this equation of latus recta, this is nothing but latus rectum. End points of latus rectum. The line equation is called equation of latus recta. That is x is equal plus or minus AE, where A is this point here, E is an eccentricity. E is nothing but eccentricity. Already we know about eccentricity. What is eccentricity? We know about that one. And equation of directrix. Here. So here we have two directrix, that is L is equal 0 and L dash is equal 0. Those are x is equal to plus or minus AE. One is plus AE and other is minus AE. This is all about equation of directrix here. And the next one, length of major axis. If you want to find the length of major axis, this is major axis here. If you want to find the length of major axis, just you can find by using 2a. Length of minor axis, then 2b here. This is 2a and this is 2b. This is all about length of major axis and length of minor axis. And length of latus rectum, here this is the length, the distance between these two end points of latus rectum is nothing but length of latus rectum. Length of latus rectum here. So it will become 2b square by a. 2b square by a. You can substitute a and b values in this expression. You can find the length of latus rectum easily by the standard form of ellipse here. And this is the most important point here. If you want to find the eccentricity of an ellipse, that is x square by a square plus y square by b square is equal to 1. That is equal to square root of a square minus b square by a square. So here this is the most important point to find the eccentricity of an ellipse, that is equal to square root of a square minus b square by a square. This is the important formula here. And sum of focal distance here, here, S dash is equal to AE. You can substitute A and eccentricity value in this expression. You can find the sum of focal distance here. Here two focal distances are there, S dash here. And the next one, distance between foci here to here, the distance between these two, S and S dash, you can find by using 2a. Foci, distance between foci here, 2a here. The sum of focal distance is 2a, distance between two focus is 2a. Sum of focal distance, SP and SP and SP dash. For example, if you take any point P on a ellipse here, SP and SP dash, sum of these two, SP and SP dash is equal, directly you can substitute by A to A. Already in last case we have discussed about to find the standard form of ellipse x square by a square plus y square by b square is equal to 1 here. And the distance between foci to AE and the distance between vertices, if you want to find the vertices here to here, the distance between here to here, A and A dash is 2a, again 2a here. And the distance between directrix, here to Z to Z dash, 2a by E, 2a by e. You can substitute a and eccentricity value in this expression. You can find the distance between two directrix points here, that is z and z dash here. This is all about the first case of ellipse, that is x square by a square plus y square by b square is equal to 1. And the next case is x square by a square plus y square by b square is equal to 1. That is when a is less than b. And if you discuss about this point here, this is axis here. So let us take ellipse. This is an ellipse here. So for this an ellipse, the standard form will be x square by a square plus y square by b square is equal to 1, where a is less than b. This is second case where a is less than b. If a is less than b, y axis becomes major axis, x axis becomes minor axis. In previous case, a is greater than b, in standard form of ellipse, x axis becomes major axis and y axis becomes minor axis. In this case, x axis will become minor axis and y axis will become major axis here. So ultimately this is having center C. The first point is considered center as 0, 0, and the second point vertices. What is meant by vertices here? The point of intersection of ellipse to a major axis. What is major axis is here? Y axis is the major axis. The point of intersection of ellipse to a major axis at 2 points are called vertices. This is A dash and this is A here. Those points are 0, plus or minus here. What is it? 0, plus or minus B here. 0, plus or minus B. 0, minus B and 0, B. And the first point and the second point here. And the next one, foci. What is meant by foci here? The plural form of focus is called foci, and here two focus are, this is S and this is S dash. That is 0, first one is 0, BE and the second one is 0, minus BE. And the next one, Z dash directrix 0, plus or minus BE. Z dash. A directrix is intersecting to major axis at 2 points Z dash and Z here. Then the points Z and Z dash point here, this line is L dash is equal 0. This line is equal L is equal 0 here. And the points for this intersection of major axis to two directrix of a ellipse here. Here this is the point here 0, plus or minus BE. For this one AE, this is minus BE, plus or minus BE. This is important point for here. And the next one, end points of lattice rectum. End points of lattice rectum I am taking. This is a line which is intersecting. This is end point. This is assuming K and K dash here. So the end points of lattice rectums are plus or minus A by B, plus or minus A by B, plus or minus BE. So you have to remember each and every different cases and different points for ellipse, then only easily to crack the problems in JEE. Otherwise you can't able to understand the concept, otherwise you can't able to solve the problems here. And the next one, equation of major axis. What is major axis here? The y axis is called major axis for this ellipse. So the equation will become x is equal 0. And what is minor axis here? Minor axis is nothing but the x axis is called minor axis. Then the equation will become y is equal 0. And equation of lattice rectum, here this is end points of lattice rectum. Then the equation of lattice rectum will be y is equal plus or minus BE. And the equation for directrix here, y is equal plus or minus B by E. Just the difference is here E eccentricity is multiplied and here eccentricity is divided. Here also every same eccentricity is multiplied, eccentricity is divided. Sorry. divided. So this is a shortcut trick to find. Shortcut tricks to identify and to remember here. And the next one, length of major axis. Here, if you want to find the length here to here, this is the formula 2b here. Here, the length of here, this is for major axis, this is for minor axis. Minor axis is 2a, major axis is 2b here. That's it. And length of flattest rectum. Here, if you want to find k dash, length of flattest rectum, that is 2a square by b. 2a square by b. You can substitute a and b values here. And this is the most important one, eccentricity. Eccentricity of an ellipse, x square by a square plus y square by b square is equal to 1 when b is greater than, a is less than b here. So the eccentricity will become square root of b square minus a square by a square. Just reverse of these 2 points, these two values will get the eccentricity. And the sum of focal distance SP S dash P is equal to b. I am taking a point here P and here. SP and S dash P is equal to 2b. This is the point here, and the distance between foci here to here, S to S dash here 2b, and distance between vertices here to A dash, A dash is equal to how much here, 2b here. And the final one, distance between directrix here to Z dash. Z to Z dash is equal to how much we have, 2b by E, where you can substitute A, B and eccentricity value. This is all about the case number 2, that is x square by a square plus y square by b square is equal to 1 when a is less than b here. Here in these two, case 1 and case 2, both are having here center is 0, 0. For these two, case 1 and case 2, both are having center as 0, 0. This is center and this is center, 0, 0, 0, 0, O here. And these two are center for alpha, beta. Center is, this is center and this is center. Center is alpha, beta. Sorry. And the next, here the diagrammatical representation for this one, the third case number 3 here. So diagrammatical representation for this one, I am taking axis. This is axis here, and for this axis I am taking an ellipse. This is an ellipse. So here this is an x-axis and y-axis. So if you observe here, these red lines are axis x and x dash, and this is y dash here. So these black lines are called major and minor axis. This is major axis and this is minor axis. And here this is a 0, 0 is a origin center for this ellipse for previous two cases, but here this is the center for this ellipse. This center can be considered as alpha, beta. This is the first point here. The center is alpha, beta. It is somewhere to coordinate axis. In the first quadrant of coordinate axis, that is alpha, beta I am considering, and that point is point of intersection of major and minor axis, that is called alpha, beta. So that's why this is the center is alpha, beta. And the second point, vertices is nothing but the line, the ellipse and the line major axis both are intersecting at points are called vertices here. This vertices is A and A dash here. So the points are alpha plus or minus A comma beta. This is alpha plus A comma beta, and this is alpha minus A comma beta. This is first point, this is second point here. And focus S dash, this is S dash. This is S dash, this is S here. S dash is equal, the focus S dash is equal alpha plus or minus AE comma beta. Alpha plus or minus AE comma beta. Where alpha is the center of x coordinate and A is the x intercept here and beta is the y coordinate for the center here. And the directrix here. So observe here, this is not directrix, this is directrix here. The directrix which are intersecting to a major axis at 2 points, that is Z and Z dash. Those points if you want to find, this is the formula here, alpha plus or minus A by E comma beta. Here just observe clearly here, eccentricity is multiplied, eccentricity is divided, that's it. To remember these 2 points here. And the end points of lattice rectum, I am taking, this is the lattice rectum here, K and K dash. The end points of lattice rectums are alpha plus or minus A comma beta plus or minus B square by A. So you have to remember these 2 points. If you know, if you are able to understand this one, you can easily write this one. If you are able to understand this one, you can write easily this one. So these two are reciprocal to each other. So now the equation of major axis. Equation of major axis is, that is y is equal to beta. Why? Because here y coordinate is, this is major axis, then y coordinate will be beta. Next, what is the minor axis? Here minor axis is x is equal to alpha. Why? Because here minor axis y axis, this one here, then x is at point alpha, so minor axis is equal to x is equal to alpha. And the next one, equation of minor axis, what will be the equation of minor axis? X is equal to alpha plus or minus AE, x is equal to alpha plus or minus AE. And the end points of equation of lattice recta, x is equal to alpha plus or minus A by E, x is equal to alpha plus or minus A by E. And the next one is equation of directrix. This is one. Equation of directrix, this is this one. And the next one, this is length of major axis. This is the length of major axis and length of minor axis, that is 2A and 2B here. And length of major axis, length of minor axis. And the next one, length of lattice rectum. If you want to find the length of this lattice rectum, K dash, that is 2B square by A, like this one. These two are same for this ellipse here. And the eccentricity is same as this one here, A square by A B square minus A square, square root of A square minus B square by A square. And the sum of focal distance same as in every case focal distance is common. Why? Because the ellipse is everywhere is same. If you rotate anywhere and if you keep center as origin, if you keep center as alpha comma beta, any case the sum of focal distance is common 2A, and distance between foci here, distance between foci is 2AE. The distance between foci is 2AE. And next one, distance between vertices is 2A. Distance between vertices here to here, that is 2A. This is A and this is A. The distance is minus A, this is plus A, that will be 2A here. And final distance between directrix, that is Z dash, 2A by E. This is same like this one, this is same like this one. So the distance between directrix here to Z dash, that is 2A by E. This is the all about the information, the standard form of ellipse, that is x minus alpha whole square by A square plus y minus beta whole square by B square is equal to 1 when A is greater than B here. So where alpha comma beta are center of a ellipse here. X minus alpha whole square by A square plus y minus beta whole square by B square is equal to 1 whenever A is greater than 1. In this case, the center is alpha comma beta. You have to remember this point here. And the fourth case is here, the final case, fourth one, same as third case, just reciprocal of third case here. This is case 4 here, case 4, case 4 here. So the standard form of this ellipse is, x minus alpha whole square divided by a square plus y minus beta whole square divided by b square, that is equal to 1 here. When a is less than b here, this is all about the expression of ellipse when alpha comma beta is having center for the ellipse and a is less than b here. This is the expression here. I am taking diagrammatical representation for this ellipse. This is coordinate axis here, x and x dash, y and y dash. This is the origin, but I am taking ellipse for this one is like this. This is an ellipse. I am taking axes here. This is one, this is one more. This is major axis. Why? Because it is having focus and all. This is minor axis. This is major and minor axis. So it is having the point of intersection of major axis and minor axis, that is called center here. So the center is apart from the center is far away from the origin here. The center can be considered as C, that is alpha comma beta. The first point is alpha comma beta, and the second one vertices. Vertices is nothing but here the points which are intersecting to major axis with an ellipse is called vertices here. This is A and this is A dash here. So the points will be alpha comma beta plus b, 1 point and beta minus b, 1 more point. This is alpha comma beta plus b and alpha comma beta minus b. Here these are the 2 points we have here. And the focus, what will be the focus here? This is 1 point and this is 1 point. This is S and S dash. Focus are alpha comma beta plus or minus be is a focus here. 1 point is plus, one other point is minus. Alpha comma beta plus b and alpha comma beta minus be. So here this is all about the focus here. 2 focus are there here. This is E here, and next one is directrix. Here directrices are nothing but the directrix which are intersecting to major axis at 2 points. This is Z and Z dash, and those points are alpha comma beta plus or minus b by e, where this is multiplied to eccentricity divided with eccentricity. 2 cases are there here. And the next end points of lattice rectum, a line which is perpendicular to major axis as well as passing through focus and intersecting at 2 points is called lattice rectum. The end points on an ellipse are called end points of lattice rectum, that can be considered as k and k dash here, and these points are alpha plus or minus a by a square by b and beta plus or minus b. You have to remember this one. This is just reciprocal of this one. In every case this is just a reciprocal one, this is just reciprocal to this one. So you can easily remember all the points by using this concept here. And equation of major axis. What is equation of? This is major axis. This is major axis. This is parallel to y axis. Then equation of major axis will become x is equal to alpha with having x coordinate is alpha, and y is equal beta which is having minor axis. Y is equal beta, that is equal to which is having beta here, and this is minor axis. Equation of minor axis. And then equation of lattice recta here. Equation of lattice recta, then equation of lattice recta will become, this is lattice recta, then the equation of lattice recta become y is equal to beta plus or minus b e here. And the next one is equation of directrix. What is equation of directrix here? We have 2 directrix, that is L is equal 0, L dash is equal 0, L is equal 0 this one, and the L dash is equal 0 this one. Then the equation of directrix will become y is equal beta plus or minus b by e. And the next one is length of major axis. This is length of major axis, that is 2b. Length of minor axis, that is 2a. Just this is the reciprocal to this case 3 here, reciprocal to case 3 here. And the length of latex rectum, if you want to find the length of latex rectum here, these two here to here, k dash, that will be 2a square by b, same as this one, case 1 here. So the eccentricity is same as case 2 here, square root of b square minus a square by a square here. So here this will be common here. SP plus S dash P here, sum of the focal distance is 2b here, and the next one 2b, distance between focus here to S to S dash, that is 2b, distance between focus here, and the next one distance between vertices, B dash is equal to 2b here, B dash is equal to 2b, distance between here what we call distance between vertices, here to here, the vertices will be 2b here, and the distance between directrix 2b, Z dash is equal to 2b by e. This is all about the different cases of 4 ellipse here, and their terms. We have discussed about 4 different types of ellipse and their figure, center, vertices, foci, directrix, endpoints of latex rectum, major axis, minor axis, latex rectum, equation of latex rectum, equation of directrix, length of major axis, minor axis, and latex rectum, eccentricity, most important, sum of focal distance, distance between focus, vertices, and directrix here. This is all about this class here. In next class we have to discuss some more points of ellipse here. Thank you.